Okay, a little bonus coverage here. I'm going to continue what we've been looking at in sections 1, 2, and 3 by looking at a type of an equation that's going to use some of those same steps that we've been discussing, but it's going to seem like it's going to have a whole lot more variables in it. And we're going to call it a literal equation. The definition of a literal equation is an equation in which coefficients and constants, the numbers, have been replaced by letters. Now, sometimes we have some numbers still in the equation, and we typically call those formulas or just equations that have multivariables. But in this case, we're going to look at our very first example, an equation, a literal equation. It has no numbers, but we are solving for x. It says solve for the indicated variable. We're solving for x. So we're going to treat the a, b, and c as if they were numbers. Now, of course, they're unknowns, so we can't combine. We can't add a and b and get c. So what we're going to do is we're going to solve for x by isolating it using some of the same steps that we've been discussing, where you can add to the same side, subtract from the same side, and so on. Now, in this case, my unknown x is being multiplied by a, and there's a b being added to that. We know to undo adding and subtracting first, so the first thing I'm going to do is I'm going to subtract b from both sides. Using a little shortcut here, notation, I have ax is equal to, now I have c minus b. These are not like terms, so I have to write c minus b. I have to. That's what this expression is equal to. Now I'm going to get rid of the a that's times the x by dividing both sides by a. Now, as it turns out, a doesn't divide into the expression c minus b, so my answer, although kind of unusual looking, is x equals c minus b all over a. Now, literal equations sometimes will be on the proficiency test. Not every single proficiency test has literal equations, but we want to be prepared all the same. Next example is more of an equation that has two variables, which we will discuss in Chapter 8 in greater detail. And there are some numbers in this one, but there are two variables. We're solving for y in this case. We're solving for y, not x. I know we almost always solve for x, but we're solving for y. So I'm going to undo the stuff around it by getting rid of the negative 5x and getting rid of the 3 in this first. Now, because of the negative, I'm going to add a positive 5x to both sides. And I get 3y equals 12 minus 5x. Or if you want to, you can write 5x plus 12 because of the commutative property of addition. One more step like I had over here, and that's to get the y all by itself by dividing. Now here's where the temptation may come into play. You may think, well, I can divide 3 into 12. Well, 12 is not all that you would be dividing into. You'd also be dividing into the plus 5x. And since we don't know if 3 goes into all that expression, we're just going to leave it as 12 plus 5x all over 3. Didn't give myself very much space, so you can read that all right. This is a very simple formula in that it's finding the perimeter of a square. Now, we normally have p all by itself and we plug in for s, but this time we're going to solve for s. One step can do this one. We have to get rid of the 4 that's times it. So I'm going to divide both sides by 4. This is a pretty simple one compared to the other two. And I have p over 4 is equal to s, and that's it. I can't divide 4 into p. That's as far as that one goes. Here's another formula. This is the perimeter of a rectangle, and I'm solving for w this time, right over here. I have two other letters, and I've got a couple of coefficients in there, so I have to be extra careful. I'm going to undo the stuff around the w, get rid of the 2l that's being added to it, and get rid of the 2 that's times it. And I'm going to get rid of the 2l first, and I'm going to write it out the long way, at least that's what the students keep calling this, the long way. It's the proper way. And I have p minus 2l, which is p minus 2l. But over here, the 2l's are going to cancel, and I just have 2w. One more step. I've got to get rid of the 2 that's times the w. I'm going to divide both sides by 2. And again, there's that temptation to think, well, if you cancel the 2's here, why can't I cancel the 2's here? Well, in this case, this 2 is a factor. In this case, this 2 is part of a term. And you can't cancel terms or parts of terms by dividing like this. You would have to divide the 2 into the entire expression, which I'm not going to do. And there is my answer. These types of problems, like any other kind of equation, you can get better with it as long as you take the time to practice, practice, practice.